Now, I'll step away briefly on the concept of software-defined networking, and I'll focus on another technology, which is virtualization. Okay, so you may have also encountered this while you were answering the Kahoot quiz just at the start of the session, that there were discussions on what is a virtual machine, what is virtualization, no? Um, to put it in simple terms, virtualization, this is just a technology that allows us to run um, multiple computers, quotes there, multiple computers inside one physical computer. Okay, so all of us nowadays, so before I discuss this slide, no, which is what is NFV itself, no, I'll briefly discuss what is virtualization. Um, Majority of the computing that we are doing nowadays, no, normally runs, say you have a desktop or a laptop, right? So general purpose computing, that's what I'm referring to here. If you want to say run an application in your computer, you have to make sure that that computer has an operating system, and that operating system is able to run your application. So just by, in fact, just by having this session alone, you are already using general computing, right? So you might have your Windows laptop, Windows desktop, or a Mac, in fact, no? So the point here is that you have a physical general computer on hand. Okay. Functionality wise, that physical computer you have right now is only able to support one operating system, right? This is an exemption, of course, of dual boot systems, but that's a different topic altogether. I'll focus here really more on your physical device. You have one physical laptop, one physical desktop, and it is being worked on by a single operating system. Windows, Linux, Mac. You get the point. Okay. Now, imagine now that, say, you have an application that is only able to run in a Linux environment. So, say I have this application and it only runs in example, Debian or Ubuntu. And I want my machine to be able, or I want to use that application. So what do I do? No, back then you would have to purchase a separate physical machine, install an operating system there that is able to run your application. So say now I have two physical machines, one for Windows and then the other one for the application that I just want to run under Ubuntu operating system. So notice there, just by that simple example alone, you already have a considerate amount of machines, right? I mean, nowadays, why would you even have more than one laptop, no? Running two simultaneously operating systems? You've already spent twice as much hardware just for you to run two operating systems, for you to just run a single application. So it's not really cost effective. Right? In a personal sense, why would you do something like that? Right? Put that same mindset in an organization, in, say, an enterprise or in a company. And this company is able to host several applications, and each of them are running or is only compatible to run using only a specific operating system. My point here is really on the operating system model. So meaning that this organization would have to purchase a separate server for that application, install an operating system just for that application alone. So you already have spent a considerate amount of your capex just putting up that single server alone, right? So it's not really that practical, no, just for you to run a single application. Now, what if now, instead of having two separate physical machines, you just have one, but that single machine is able to run two simultaneous operating systems at the same time. So that is virtualization. Okay, it allows a physical machine, a general computing device such as a desktop, a laptop, or a server, no, to run two operating systems concurrently at the same time. Okay, this comes already in the form of what's called virtual machines, right? So a single virtual machine is able to support a single operating system, but they are working independently to other virtual machines also running their own operating systems. So that's how virtualization works, in fact. And for you to implement that, you need a special piece of software called the hypervisor, which is responsible for creating their virtual machines, right? So that's how, in general, virtualization works. Now, put that context, put that same technology within the telco perspective, meaning now that, say, a network element, say, a packet core network element, it runs its own operating system. And for that carrier for that operator to have the packet core network element, have, say, a packet core service such as 5G, no, run that service in their network, they have to purchase a separate hardware just for that packet network alone, right? So it's a bit not really cost effective still. But what if I already have an existing server and using virtualization, I can now have that same packet core service without having to purchase a separate hardware for it. That is NFV. Okay. What you're essentially doing is that the network function or the network service, you form it as a virtual, you deploy it as a virtual machine, and it now becomes a virtual network function or a VNF, right? So having said that, what is NFV now? So NFV, this is a way to virtualize servers or services such as gateways, routers, firewalls, and load balancers that have traditionally been run on proprietary hardware. These services can then be run using virtual machines on commodity hardware. So the commodity hardware being referred to here are your general computing hardware, such as your servers, no? Or in a more technical term, commercial off-the-shelf, which allows network providers or operators to run their network on standard servers instead of proprietary ones. Back then, when you have traditional mobile broadband implemented by a telecommunications company, if say they want to roll out, say, the 4G wireless technology in the network, they have to purchase a separate dedicated hardware from a provider just to offer that service alone. So some of them you are already aware of, like Ericsson, Nokia, Huawei, among others. No? So if, say, in my network I want to implement 5G, and 5G is just available as a dedicated hardware from a specific vendor, then I am bound to purchase the entirety of my core network, no, from that specific vendor alone. But through NFV, suppose I have existing hardware, say servers already at hand, and I want to deploy 5G as in my network. I don't necessarily have to purchase the hardware from the vendor manufacturer offering the 5G network elements. Instead, I can just take their software and deploy it using virtual machines in my existing hardware. Okay, so with NFV, dedicated hardware is not needed every time you deploy a new network function. NFV improves scalability and agility by allowing service providers to deliver network services and applications on demand without requiring additional resources. Okay, so if we're going to compare now, the appliance-based deployment normally in a carrier perspective, no, you would have something similar to this. Say, a carrier network wants to deploy they want to deploy a firewall. Normally, what they would do is that the firewall itself, it would come as a hardware, no, pre-bundled already with the hardware dedicated as a firewall, with the operating system in order to deploy the firewall service. Okay, you can put the same idea in deploying 5G. Say one of the network elements used for 5G is the packet gateway or the PGW. No, so if say I want it to be deployed as an appliance-based setup, I have to purchase a hardware only intended to work as a PGW or a packet gateway, purchase software that would only be used for PGW, and then deploy it or integrate it to my existing network. So the question here is that, can I reuse my PGW to serve as a firewall in time? Of course not. Okay. So this is where NFV would come in. It allows us to already have a more flexible approach on how we can deploy our network elements, specifically on the hardware side. No? Because we are already removing or decoupling again the concept of the services from the hardware. It is easier for us to scale or to manipulate the hardware as needed. Now, apart from this decoupling, there is also an additional component introduced by NFV, which is called orchestration. No? So that's the green box here that you're seeing here in the NFV architecture. You need a way to manage all of your network elements, right? So you're already using servers, and alongside with it, virtualization as a means of deploying the network elements. Now, in a typical fashion, this can already be deployed using your cloud, right? So normally, in fact, nowadays, if you want to deploy your cloud, or sorry, you want to deploy NFV, it already also comes pre-bundled. You use cloud computing as a means to deploy or to manage your servers, right? So we know, or there is a separate course, in fact, for cloud computing there. And cloud computing is just a means for us to centralize the management of the different resources. And these resources come in the form of your servers, your switches, your storage nodes, no, your applications, among others. OpenStack, in fact, is one of the examples of your cloud operating systems or your cloud management software that would serve as your orchestration component in your NFV. Okay, remember, because we're not just talking here of 1, 2, 3 servers anymore. We're talking here of hundreds, in fact, thousands already of servers. And you need a way to manage them all centrally. And think of it this way. Think of this scale, in fact. Imagine one server is able to support 10 or 20 virtual machines. Each of those virtual machines have their own operating systems. And normally, a typical data center where a cloud would be physically residing is able to, say, have 800 minimum servers. No? So imagine the scale. How are you able to manage those individual servers without a single pane of glass again? So like also in your SDN environment. So this is where the orchestration part would come in. Okay. Now, NFV, similar to your SDN, has its own sets of, or it has its own standardized architecture. So this architecture was developed by the European Telecommunication Standards Institute, or ETSI. So it helps to promote better stability and interoperability of different participants or vendors and even operators when they want now to deploy NFV in their network. Okay, so what you're just seeing here right now is in fact a simplified architecture of NFV. You have there now your infrastructure layer, your NFVI, you have your network elements. They would come now in the form of virtual network functions. This is also where your applications would now be residing. And all of them are being managed by a single node called the management and network orchestration, or management and orchestration, called MANO. Now, the MANO itself is consisting of several parts also, the orchestrator, the VNFM, and the VIM. Okay, so this is a completely different architecture altogether from SDN, right? Virtualization comes here in this portion, in the NFVI. So you'll notice here, you have your virtualization layer in the infra. So this is where majority of the instantiation would also take place. This is the layer responsible for creating the VMs. The servers are residing here. No? In fact, not just the servers, but even your storage nodes and even your SDN switches can be found here in the compute storage and network hardware layer. All of these constitute your infrastructure. Okay, now, how do I now overlay my SDN to NFV, right? Because there's definitely an interoperability between two. Think of it this way, although I don't have a slide for that dedicated here, I'll just explain it here. No? Remember that in your SDN, you have your application layer, you have your control layer, and then you also have your physical layer or your switches. The application layer, that is where your applications or services would run. The control layer, this is where your controller would reside. And finally, the infrastructure layer, this is where your physical switches would reside. Now, take that vertical stack and flip it to its side. Now, the controller is actually part of this architecture, the virtual infrastructure manager. It forms a part. Now, in our course, we go deep dive still on the different components found inside your NFV. But my point here is that you can implement SDN inside NFV, or sorry, that's right. You can implement SDN inside NFV by overlaying the controller inside your infrastructure manager. The switches themselves are already the resources found in your NFV, specifically the hardware resources. So that's how you can actually overlay SDN inside NFV. But in the bigger picture, how does the two technologies now work? How does now SDN, NFV, and OpenFlow work side by side? No? I'll just use this one as a simplified diagram. Suppose now my organization wants to implement a virtual firewall, or let's put it again in simple terms. Suppose the organization wants to implement a firewall in their network. Normally, what you would do is that you just purchase a box. That box can already be a firewall. It has all of the components needed here. But again, it is just isolated to a single device or to a single entity or a network element. When you deploy NFV to your firewall or deploy a virtual firewall as a virtualized network function, you can have all of the components in theory completely disaggregated with each other, meaning that you can have your hardware residing in one location. You can have the operating system running on a different location. And in fact, the service is running on a completely different location altogether. So in other words, geographically speaking, they are completely decoupled from each other. It's not possible, right? So, and in terms of their management, it's now also possible for you to say, have everything as one logical entity, but in the physical aspect, they are completely disaggregated. So you need a way to manage all of these resources together so that when the network sees it, it just sees there a single virtual firewall. How do you do that? You use SDN. SDN would serve as your underlying transport layer, able to glue all of the different components together so that in the network's perspective, you just have a virtual firewall. So I put it in real life terms. Suppose, say, your server is residing in the Visayas region, your storage is residing in NCR, as well as your network devices, and the virtual firewall itself that it is catering to, it's in North Luzon. So that's how disaggregated everything can be. Okay, now Similar also to SDN, NFV can also have their own sets of advantages and disadvantages. Perhaps the organization do not want that completely disaggregated structure altogether. It is also fine. Okay, so NFV and SDN are not really dependent with each other, but they do share some similarities and they are in fact complementary. SDN separates network forwarding functions from the network protocol functions with the goal of creating a network that is centrally manageable and programmable, while NFV is responsible for abstracting the network functions from the hardware. In other words, through NFV, you can also deploy virtual switches that can be used by SDN. So you can do it the other way around, in fact. So NFV supports SDN by providing the infrastructure on which the SDN software is able to run inside. So you can think of them as really complementary technologies with each other, right?